Hello everyone, today I'll talk about the solution to the problem largest number. We're given a list of numbers and we can change the order of the numbers in the list however we like, and we want to do it in such a way that when at the end we take all those numbers in order, we join them together, we concatenate them into one big number, one long number, the value of that number is as high as possible, right? So to create the biggest number by gluing together all the numbers that were given in any order that we want. So let's start with the standard comparisons between numbers. How do they work? When you have two numbers a and b and you want to compare them together, what do we have to do? Because we know that we want to compare digits with each other and that smaller digits are smaller than big digits. So there is this aspect of lexicographical ordering, so alphabetical essentially ordering, but this is not the only thing that we need to do, for the simple reason that first we want to compare their lengths. Right? So if two numbers are the same length and we discount leading zeros, then we can compare them lexicographically. Or another way of seeing that is that if we have two numbers of different lengths, we can just fill the smaller number with leading zeros and compare lexicographically. And the leading zero is smaller than whatever the other number has, so that then the ordering is okay. So for instance, if we have comparing 9 with 12, then we cannot just compare them lexicographically because 9 is bigger than 1. But if we add a 0 here, then everything is okay. So this is something like lexicographical ordering, but we have to look at length. This is, of course, standard. And our final result is probably going to have to be of length equal to sum of lengths of all the numbers that we have had at the beginning. So all the numbers in nums. The only case in which it's not going to have that is if we have only zeros, because then the number is 0. Because as long as we have something that's not a 0, we can put all the zeros at the end and get a bigger number. So essentially the final number has to be the lexicographically largest concatenation of everything that we have at the beginning, saving for that final edge case. And we know that for problems that ask us to get the smallest or largest lexicographically value from some building blocks, then typically we can do it greedily. We can always at every step select the best value, the value that will give us the biggest number, and it'll typically work. So, of course, in this case, so how do we start our number? Well, we want to start it with a 9 if possible, because anything that starts with a 9 and has that given length is better than anything that starts with anything else. So we know that even though this 9 is smaller than 12, if we had this test case containing those two numbers, then certainly 9 will be earlier than 12 in any number that we create. Because at the position that it appears in the number, so let's say that I have created the final number, there is something happening here, then we have a 12, then we have something happening here, then we have a 9, then for sure, if we put the 9 here and swap it with the 12, then at this position the digit will increase, so the final number will also increase, because its length will not change. So at this point you might think, great, what's the problem? We know what to do. We have to take the numbers that start with the biggest digit, put them at the beginning, then those that start with smaller digits, and so on. So first we take everything that starts with 9s, then with 8s, that will get us the biggest number. However, there is one situation where we're going to get into problems. Because consider that we have a number 3, and then we have 32, or we have 34. What order should those pairs go into? Well, of course, here, the better option is to get the 3 in front of 32. However, in this case, we want the 34 in front of the 3. So, if we just sort the numbers that were given lexicographically, the 3 will be before both of those. Here it is okay, here it's not okay. If we, let's say, add some digits or some letter that's bigger than anything else after the numbers, then this first case will break because the 3 will be after this 32. So how do we sort the numbers if we cannot easily tell, or at least we don't now see how we can easily tell, which number is bigger than the other, which number should be before any other? And of course the source of our difficulties is exactly when one number is a prefix of the other. In the situation where there are only two numbers, we know that we can just compare AB with BA, We get, for instance, that AB is bigger than BA, and that's great. We just take the better option. However, as it turns out, we can actually sort all the numbers by using this thing as a comparator. And so essentially, we just compare any two numbers. So when we want to compare A with B, we take AB, we take BA. So the two concatenations, we compare them. And it is a correct comparator, as it turns out, but I'm not aware of any elementary proof of why that is. Because essentially one way of proving that would be to show that in this case, if AB is better than BA, BC is better than CB, then also AC is better than CA, is bigger. And it's possible to prove it by using some powers of 10, so 10 to some power, because we know that the value of those concatenations is this A is shifted to the left by the number of digits in B, so it's multiplied by some power of 10. In this case, this B is shifted to the left by the appropriate power of 10, so the number of positions, that's the length of A. And we can then take A on one side, B on the other side, do the same with the second equation or inequality, and we can get at the fact that this here is also greater than. So we have transitivity, and we can then use it as a total ordering, sort the numbers by it, and this will give us a solution. But I'm not aware of any better, simpler proofs of the fact that this approach actually generalizes, works for our problem. This is especially surprising to me because here we of course don't use the fact that it's only the situation where one number is a prefix of the other number. When trying to prove it, we just prove it using simple mathematics. And it really feels like there should be an easier way of showing that. But I don't know it, so if you know it, then feel free to share it. So if we can convince ourselves that by comparing those numbers with each other and deciding that one should go before the other if they are the only two numbers, that also means that one should go before the other in other cases when we want to create the biggest number, then we can implement our final solution to the problem. So how do we implement sorting using that interesting comparator? Well, the comparator will just take the right-hand side, the left-hand side, and concatenate them together, so adding strings concatenates them. And now, if we want to sort using this comparator, we know that in Python we use keys and not comparators. And the key is a function that for every value generates the key, then sorts the values based on the values of their keys. And this is pretty maybe difficult because there is no key for those numbers, 3 and 32 and 34, because, and of course we can have more difficult cases, it's tough to get a key that will not depend on the other value. We want to compare those two values that we get by concatenating the left and right hand side, and so we would have to get some way for the key to be able to take into account both the values that we're comparing. And it's possible to do so. We essentially have to get a dummy value, and that dummy value will, during comparison, actually calculate the thing that we want to calculate. And in Python, we can use the CMP toKey function. So we can write a simple comparator, and the comparator here wants the values to be either negative, positive, or 0, depending on which number is bigger, which value is bigger. And this is a standard old-school comparator, as you would also see in maybe C or C++, which is essentially equivalent to just subtraction. So, because this subtraction, it will give us either that one number is bigger than the other or smaller, or if it's 0, it gives us that they are the same. So, we take that comparator, change it into a key, and it's a key that we'll be sorting. What will we be sorting? Well, we'll be sorting the numbers. Since we want to join them together, we can treat them as strings along the way. This is just an implementation detail, and of course we want to sort them. And after sorting, we just join them into one big number. So this is the sorting using this comparator by just comparing the two positions that they can be with each other. And at the end, of course, we have this edge case. If the final number is 0, so in other words, if the biggest number that we have created starts with a 0, that means it's all zeros. We don't want to return multiple zeros, we only want to return a single 0. So again, the implementation is pretty simple. This cmp2key function is useful, and it might be something that some people are unfamiliar with in Python. And of course, actually getting a nice proof of this, of the fact that this comparator works, would be pretty nice.